remember, total momentum in the x before the crash, it should be equal to after the crash because momentum is conserved. So I just rewrote that equation in a slightly different way to show that the total momentum in the x direction is actually made of the momentums of two objects. The momentum of object 1 in the x direction plus the momentum of object 2 in the x direction. And notice that object 2 is not even moving, so it's going to have zero momentum. That's going to end up being a zero term. And then after the crash, the same is true, right? So that has to equal the momentum of object 1 in the x direction plus the momentum of object 2 in the x direction. So this is the same equation as before. I'm just showing that the total is made up of two objects before and after the crash. And so what is momentum? Remember, it's a mass times velocity. So this can be replaced as m1 v1 plus m2 v2. And I'm going to add some x terms on those velocities to show that we're talking about the x direction specifically. So the momentum of object 1 plus the momentum of object 2 before the crash should be equal to the momentum of object 1 plus the momentum of object 2 after the crash. So you're going to notice that both sides of the equation are identical because, again, if you add up their momentums before and you add up their momentums after, they should be equal. And now we can start kind of modifying these terms because I need to give you some masses. So let me give you a couple of masses. Okay, so for this problem, let's say that m1, the mass of the cue ball, the white ball, is 0.17 kilograms, and m2, the mass of the other ball that I showed in black, is 0.16 kilograms. These are pretty reasonable numbers for real pool balls, and the cue ball does typically have a little bit more mass than the other balls, so we're going to go with these two numbers. And so we can start plugging m1 and m2 into our equation, and we can also change this v1x and v2x term because if you look at v1, this velocity of ball 1, it's in a diagonal direction, which means it's made up of an x component and a y component. And so what is the x component of this diagonal vector? It would be v1 times the cosine of this angle. And if you did v1 cosine of the angle, that gives you the x component of this overall velocity. So for m1, I'll put in the mass, 0.17 kilograms. And then for this v1x, I'm going to put in v1, so 10, but it's going to be times the cosine of 30 degrees. So remember, it's the velocity times the cosine of the angle at which it's moving. And then, so that gives me my first term. What about m2? That's going to be 0.16. So I'll just put 0.16 times the velocity of ball 2 in the x direction. Well, that's just 0. It doesn't have a velocity at all. So I'll put a 0 there.